Hello, this is Schedulytics. Welcome to today's session. In today's brief video, we're taking a look at effect size. We will demonstrate this using JASP, and as we do, we will come to appreciate its application when it comes to statistical analysis and by extension, research in general. Well, have you watched our video on inferential statistics? If your answer is no, then we encourage you to watch that particular video, Inferential Statistics, right here on the channel. In that video, briefly, we explain that inferential statistics has to do with drawing conclusions about a particular population based on a thorough analysis of a sample that had been obtained from that particular population. Now, in drawing this conclusion about the population, we either fail to reject what we call the null hypothesis. Now, before one can be able to reject this null hypothesis, we calculate what we call the p-value or the probability value. Now, when the value is greater than 0.05, then we fail to reject the null hypothesis. On the other hand, if the p-value is less than 0.05, then we reject the null hypothesis because there is enough evidence to do so. However, a situation can arise where a lower p-value sometimes can be incorrectly interpreted as meaning there is a strong relationship of difference between variables. Consequently, what is needed is not just null hypothesis testing, but also a method of determining precisely how large the effect size in the data actually is. And that brings us to what we call the effect size. What is effect size? It is a statistical measure used to determine the strength of the relationship or difference between variables. Unlike a p-value, effect size can be used to quantitatively compare the results of different studies. Now, what are some ways in which we can express effect size? Well, we have the standard mean deviation or difference, the correlation coefficient, the odd ratio, among others. Well, having established this theoretical basis surrounding effect size, we now want to delve into the JASP platform and see how this particular effect size or the effect size is calculated using JASP. And after that, we will see how we can interpret that particular or effect size values. So now let's go to the JASP platform. Good, so now we are on the JASP platform. We'll click here as usual. We'll click open and we'll come to data library. And since effect size has to do with inferential statistics, we'll click any of the inferential statistics like t-test, ANOVA regression, among others. So we'll click on the t-test and we'll select any of the data sets for this purpose. So we'll click here, and then at this particular column, we have what we call effect size. Effect size. And the various ways in which we can express this is we have the Cohen's d, the glass delta, and Hedges d, G. Now, when we scroll to this particular place, we realize this is the Cohen's d value. And when we click, we change that to glass delta, we find a different value. And when we click on Hedges G2, we have a different value. Good. So these are the ways in which we can express it. There are other forms of expressing the effect size depending upon the particular type of inferential statistics you are doing. For this particular one, we are doing independent sample t-test. That is why it has provided us with these particular options. Now let's see how we can be able to interpret the effect size that we obtain. Good, as we can see on the screen, we can either classify the effect size value as being trivial, small, medium, or large. Now, when the Cohen's d value, for example, falls below 0.2, we say the effect size under consideration is trivial. When it's 0.2, it's small. When it's 0.5, it's medium. And when it is 0.8, it's large. The same categorization can be used for others such as the Hedges G, ranked by Syria, ether squared, the partial ether squared, omega squared for ANOVA calculations. So the various values are listed here. And so when you obtain your particular effect size value, you come to this table and compare the value and be able to then classify it as trivial, small, medium, or large. That is not all. Other tests, other statistical tests such as correlation, effect size measures such as correlation coefficient R, Spearman's rank, Kendall's toe can also be used to express effect size, and their corresponding interpretation or classifications are also here listed. When we come to multiple regression, we have the multiple correlation coefficient and its associated categorized value and their interpretation. Finally, when we come to contingency table, a 2x2 table with its phi, we have values here that we can classify as small, medium, or large. And when it comes to other forms of contingency table greater than 2x2, we have the Kremen's V and the various values and their associated categorization into small, medium, and large. So basically, this is how effect size can be used, obtained, as well as interpreted when it comes to statistics. If you find this video very useful, we encourage you to like it. We encourage you to subscribe to the channel so you would always be notified when we release a new video. This is Schedulytics. Until we meet again, it's a bye.